Okay, so a number of the object lines have been retraced, and I thought dipping in to demonstrate a few more might be helpful at this point. So here's the pointy cutout on the right side. I drawn a construction line across where I found that point, and I'm just retracing it now. Let's see how that goes. All right, and then once that feature is found in the top view, using a set square, we can transfer to the front view what that feature looks like. In this case, it's going to look like a hidden line. So dashed lines once again. It looks pretty good. I'll need to clean up some lines here and there, which is fine. So in orthographic projection, a big part of working out the drawing is to use projection as an idea and tool to transfer information between views. It also helps you read a drawing. If you're wondering what this is in the top view, by following this line vertically to the front view, you see, oh, it's a cutout, it's that deep or that high, and it goes from here to here. So that's what those two lines describe. They're hidden because if I look down on this, you can't see those points, just like you can't see the bottom of this V-shaped cut on the top sides. So now the method we're going to use to transfer the information for the right side view, and we'll do it from the top view. These lines have already been projected when locating these points originally, so they're already there, going to the intersecting the miter line at those places. So now we'll just transfer those down, and we'll use a hard pencil, 4H. Looks good there. Yep. And then the center, which is here. And then this last intersecting point. So that transfers the information, which describes the distance from the front to the back, you could say, of where these different features are. And by using that miter line, it allows you to get the same distance here as there. So that distance will transfer to this distance. And then we also need to do it, project lines from the front view, which is what's done when I did my construction lines, when I measured to find this point here, which happened to be on the drawing 7 millimeters. And when I measured down from the top of this line down 12, I was able to draw that line. So not every dimension is given on a drawing if you're not familiar with drawings. For instance, here it says the distance from there to that point is 38 millimeters, and then the overall distance front to back is 58 millimeters, but it doesn't indicate these. Pretty common on a drawing. In this case, the reader would only assume, the only thing they can assume is that this distance from here to here is the same as the distance from there to there. And so if we subtract 38 from 58, that leaves you 20 millimeters. So this space and that space are both 10 millimeters in length. All right, so I projected over lines across and down and across to the right. Now I'm gonna pause the video and I'm gonna draw in the right side view. Actually, I'll show for a little while and then I'll pause. All right, so at the bottom, we have a solid line all the way across. At this point here, that's going to be going, if I go up, it goes all the way across the object, so I have to go from front to back, and it's going to be a hidden line again. Yeah, something like that. It's actually quite hard to do with this arm in my face. You can't see my setup. All right. And then another hidden line. Oops, sorry, that's not a hidden line. That is an object line. That's the top of the object. And then this will be a hidden line for this cutout on the top. Now, I used an H pencil. If I was doing this drawing hand in, I would use a 2H pencil to make it a little bit cleaner. I'm using an H so that it's darker for you to see in the video. All right. So those are those lines, the horizontal lines, and next we'll work on the vertical lines. So As students do this, they learn how to read blueprints because they're wondering, well, what do I draw from here to here? Well, if you look at the drawing, it's a flat face, so it goes from top to bottom. And it is a skill to take something that's drawn flat, two-dimensionally, and determine what it looks like three-dimensionally, which is why it's good to do some blueprint reading with your students once you get to teaching how to make drawings. All right, so aside from some cleanup, that drawing looks good. A few corners here, I'll erase a few lines I don't need and some measurement marks. And of course, then I'd use my Ames lettering guide and work on the title block with a 6-inch or 6mm high title and 3mm for the other, for the name, the class, the date, etc. Depending on what your title block you might use with your students looks like. So that's a 3-view drawing. Space is kept the same. I like 40. Usually it's enough to put dimensions in for simple 3-view drawings. The same technique can be used for doing 2-view drawings. So typically I'll say to students, a 1-view drawing, like the template, is for things that are flat. Templates, things they use in road work to paint arrows on in the parking lot, etc. And then when you get to objects that are cylindrical, things that are cylindrical can be shown in 2 views quite nicely. So a front view could be the rectangular looking shape, and then beside it you might make the right side view the circular shape, and 2 views would show you everything you need to know, because if you were to show a top side view, it'd just be a 90-degree rotation of the front view, which would be no point. It doesn't show new information. So typically cylindrical items you can show in 2 views with front and right side, and then things that are non-cylindrical, often it's best to do them in 3 views, top, right side, and front view. This object, if you worked on these with students, is a lot of work using a compass. They're good. A little bit different than doing something like a template. That's a similar kind of drawing. And I did have one more that I put into the, or actually more than one more. So there's a cylindrical item. Part of this object is octagonal, but it still works well in 2 views, similar to a cylindrical one. And then this is another 3-view drawing, not unlike what I just showed you, except more complicated because there are corners that have been rounded. So often that in machine parts, it's common to do that, or cast parts because they release from the molds easier, less stress risers on internal. So that's actually a fillet in there, which is an inside curve. That's called a round. And so a little more difficult to do this one because of these rounds and fillets. It's also shown in cross section as if it was cut with a saw through. And so you can see what the holes look like. These are examples of various machined holes. This one is a hole of a certain depth with countersinking, and this is a counterbore hole which goes all the way through. These lines didn't show up right in the drawing either. They should actually be center lines. This one, this one, this one, and even these should all be center lines, which are a long line with a dash and a long line. And if there's a hole or a circular feature or even radius, you would normally show a vertical and horizontal line to locate where the center is. If you look at it from the side, then one line's typical. And long line, the gap, 3mm line, and then another long line, and it makes like a bullseye when you're showing the center thing. So these ones didn't print out properly. I'm pretty sure they're okay in CAD. Anyway, so you can play with those. I recommend at least being able to do something like this. Maybe this you might do in a grade 10 class. I would typically do that in grade 10 class, no problem. Grade 9 class, I probably wouldn't. Drafting would be a challenge for a lot of students. It's unlike most things they've ever done in school. And so grade 9 classes, I'd probably stick to things like SketchUp and software, which is more available or the kids might find a little bit easier to get into, and keep the course fun and light. Up to you.